Hello, this is Mr. Warwick. I'm here to talk to you about lesson 6.5. This is trapezoids and kites. Is this 6? This is not 6.5. This is 6.6. What are you going to do? Lesson 6.6, trapezoids and kites. This is the sixth lesson from chapter 6. And we'll be talking about trapezoids and kites. These are quadrilaterals that very specifically are not parallelograms. So for once, we won't be dealing with building onto our understanding of the properties of different types of parallelograms. These are different shapes. So we'll start with the trapezoids. When we have trapezoids, we have one pair of parallel sides. Those are the bases. The bases of a trapezoid are the pair of parallel sides. So you might see the little V-style marking on there that indicates that those are parallel. The legs of a trapezoid are not parallel. And then we have our base angles. Specific to a trapezoid, if you're looking on that first page there of this lesson, is an isosceles trapezoid. You'll need to make sure to take down the definitions that they have for the isosceles trapezoid. Basically, a lot of the problems dealing with trapezoids, you'll be asking to prove whether or not they are isosceles, or given that they are isosceles, try to find some measurements, prove some points. 6.21, if it is an isosceles triangle, both sets of the base angles are congruent. So then we start looking into the converse ways to prove that it's an isosceles trapezoid. If you have one pair of congruent base angles, this one down here and this one down here, the other ones will also be, and it's going to be an isosceles trapezoid. And then on 6.23, this one is very specifically worded. A trapezoid is isosceles if and only if the diagonals are congruent. So we're seeing some of the same things that we saw from parallelograms, but it's very different. You have to understand it needs to be a trapezoid, and if it is a trapezoid and the diagonals are congruent, then we're dealing with an isosceles trapezoid. Page 441 is more information from trapezoids. It's a mid-segment. If you have a mid-segment, we have a trapezoid, and there's a midpoint on this leg and a midpoint on this leg, and they are connected. Now, the trapezoid doesn't have to be isosceles for this. The mid-segment across here is the average of the two other bases. I've put down here the top and the bottom. In a formula chart, it would be B1 and B2. You can use it to find the area of a trapezoid if you're asked to find the area of the trapezoid. But that mid-segment should be halfway in between the top and the bottom, not just in location, but also in measurement. So on this one, if the top is 6, if the bottom is 8, then this would be 7 here in the middle. Okay, moving on to our other shape that we're going to deal with today, it's kites. If you have a kite, it has two pairs of consecutive congruent sides. So if we imagine we're going to go fly a kite, then this side is congruent to this side is congruent to this side, and just as you would imagine in laying out a classic style kite, those ones next to each other are congruent. Again, it's not a parallelogram. We're not dealing with the rhombus type thing going on here. Very specifically on this, it's not a parallelogram. The opposite sides are not parallel. So if it looks like, oh, hey, we can prove this is a rhombus, but you can tell from the shape that it's not a rhombus, you're probably dealing with a kite. 6.25, again, look at page 442. Make sure to get the definitions down, get that stuff in your notes, and get these down in your notes. On 6.25, properties of a kite, our diagonals in a kite are perpendicular. So just like you would want to have that cross piece in a kite meet at that 90-degree angle, like a kite that you would fly, same thing with the shape itself. And one pair of opposite angles are congruent. And it's in between your congruent sides. Okay? So in between the sets of congruent sides. So when we have this one that's congruent to this angle and this angle are not the same. But this over here and this over here would be those opposite angles that are congruent when you are dealing with a kite. Those are the properties of a kite. That's what you look for to prove that it is a kite. Now, most of the problems with kites deal with finding missing measurements from that kite. So you're going to be dealing with the Pythagorean theorem. Refresh yourself on it. You've probably had to do it some with your work on squares, but this is going to be very specific to a kite, is you're going to be working a lot of stuff because this has to intersect at a 90-degree angle, and there's not a lot of different properties that go with kites. Most of your work is probably going to be centered around using the Pythagorean theorem to find missing sides. If you have any questions about either trapezoids or kites, remember, don't refer to the earlier videos. They are not parallelograms. And then bring those questions that you have up in class.